We're in the winter now, and the one thing that usually always raises its head, especially on farms in the winter time, is the good old battery. And generally, old batteries are the ones that show up their age when the winter comes. So, do you know how to look after your battery? You know how to best care for it? Do you know what all the numbers on the top of the battery mean? Do you know how to choose the right battery for your tractor, your car even, or your van, or your 4x4? So if you stick around for this video, we're going to talk through batteries, we're going to talk through how to look after them, and we're going to talk through how to make sure that your machine is going to start first thing in the morning when you go out and turn the key. Good evening, everybody. You're very welcome back to the Agri-Motive Farm Machinery channel. So yes, in tonight's video, we're talking about batteries, we're talking about alternators, we're talking about chargers, booster packs, battery testers, cables, and various things to go along with the battery. We're going to be talking a little bit about antifreeze and stuff towards the end of the video, but we're going to start off with the battery. So yeah, the one thing, the biggest enemy to the battery is the cold. Well, when I say cold, it's extremes of heat actually. So extreme cold or extreme hot weather. So when you look at an EV or an electric car, they operate best within the range of about 25 degrees Celsius outside. So when the battery is maintained at 25 degrees Celsius, it works optimum. That's where you're going to get your most range and your best performance out of it. If the temperature goes down into the zeros, into the minus figures, you're going to see anywhere between 30, 40, 50% less efficiency from your battery. And also on the other end of the scale, if it's too hot, the battery has to be cooled down. So you have to keep the battery cooled, and what's going to happen is the efficiency is going to be lost from the battery as well in extremes of heat. But in Ireland, in the UK, we're generally talking about extremes of cold. And this time of the year, when you go out to start a yoke in the morning, it mightn't always start. If it does start, it's going to be slower to start. And there's lots of ways, lots of things that we can do to try and avoid that, and to make sure that your tractor or your car, your Jeep, whatever, starts first thing in the morning. So the first thing you want to do is make sure that, first of all, your battery is well serviced. So obviously we've got the caps on the top here. So we want to make sure that our levels, our electrolyte levels, are right within our battery. So it's very simple. If you get a screwdriver, now this is a flooded lead acid battery. So that's 99% of batteries, especially in the agri-motive sector, are going to be flooded lead acid batteries. Now, batteries can be broken down into two sections. You can have flooded lead acid, and then you can have what's called an AGM battery. So that's absorbent glass matte battery. So modern vehicles, a lot of modern cars and that would all have AGM batteries in it. They're much, much more high performance batteries. When you've got systems like stop start in cars, and there's a very, very high demand on batteries as opposed to modern electrics and stuff that's in cars. But for us, when we're dealing with farm machinery, and 99% of the times we're dealing with a flooded lead acid battery. This one here in particular, it's a John Deere. It's one of our tractors at home. It's a John Deere battery. It's a John Deere Strongbox, and they are actually a very, very good battery. Lots of people buy these batteries to put into Massey Ferguson's and the likes, and they are very, very reasonably priced. So we're going to start with looking at what's inside the battery and just how we check the levels and what we should be putting into the battery if we find that our levels are a little bit low. So here we can see just the top of our battery. Now I'm not going to zoom in down on the different cells, but look, you just get a screwdriver, you'll take the cap off, you'll get a light, you'll shine it in, and you'll just see you might have a little plastic marker or a little where the top of the plates in the battery are, the top of the cell. They just need to be covered. Now you don't fill it up to the top. You never fill up to the top. You just look down in. You make sure, first of all, that there is actually fluid in it, and that it is just slightly over the level of the plates. So if you do find it is low, what are you going to put into it? Well, I would highly advise staying away from tap water. And that's the first thing that most people go for, is tap water. What you should be putting into it is either electrolyte or distilled water. There's too much impurities in tap water to put into a battery. Now, if you're stuck, if it's a thing that you've no other options and you need to get going, try to, get something out of the kettle. You know, you could boil the kettle, you could let it cool down, it'll take some of the impurities out of it, and then put a little bit into it. If you've no distilled water, if you're in the middle of nowhere and you're kind of stuck, boil the kettle maybe 1 or 2 times, let it cool down a bit, and then fill it. But try to avoid at all costs putting regular tap water into it. Distilled water or electrolyte is the best. So we'll just stick that back on. So after that, then our battery in our tractor or whatever it is, what we want to make sure is that obviously our 2 poles are negative and are positive. The positive is always going to be a bigger pole. So we want to make sure that they are clean. So what can we do to clean them? Now, could blow around there with an airline, with a rag, take all the dirt out of it. One of these is ideal. This is my one. This is just a battery terminal cleaner. So it comes apart like that. So it has like a wire brush in one section for doing the male part, and then you have the female for doing the female terminal. So what you'll do is you'll just run that down onto your terminal, just give it a couple of scrubs. Comes up perfect, nice and clean, takes any crap off it. You're going to get a good connection there, and then we'll flip it over and we will take our lead, our negative, or positive. These are just old ones that I have. These aren't been used in anything. So you just take that down, scrub it down into it, and you'll get the inside of it cleaned. That's it. Put it on, sticker down on, tighten it up, and you can put a little bit of WD-40 here. And some people put grease and that around them. I'd advise against putting grease around, because certain greases can be conductive, and it can attract impurities in around the terminal. But there is terminal cleaner and terminal paste you can put on them to keep them nice and clean and keep the oxygen and that away from them. So yeah, that's pretty much it on the terminal end of it. Make sure they're clean. Make sure your cells are all full up, and make sure that the battery health is good. So how do we test the battery? Well, a lot of people say, oh, get your multimeter on it, stick it on it. Well, the only thing a multimeter will do, there's my old multimeter. The only thing a multimeter is going to do is tell you the state of charge of the battery. So if I stick on my positive and my negative, I have 12. Now I know this is a good battery. I have 12.3 volts. But the only thing that the multimeter will tell me is what voltage is in the battery. 12.3 volts. Now that battery could have a short cell in it. It could have a near dead cell, and it will still give me over 12 volts. And you could put a multimeter on it, and you might think, oh yeah, well that seems pretty good. So what we would like to do is use a battery tester on it. Now, there are a lot of old school battery testers. The high rate discharge tester probably would have been the most common one in the past. The high rate discharge tester was basically a big tester with 2 handles, 2 prongs, and a gauge in the middle. And what you done was you dead shorted the battery, so straight onto the 2 clamps, and you dead shorted the battery, and you looked at the gauge, and you basically saw how long it stayed in the green for. If it went into the green and then very, very quickly dropped off, you knew that you had an issue in your battery. Similarly, you could take off all the covers off the caps off the cells. You could put a high rate discharge tester onto it, and you could see if one of the cells was bubbling when you shorted out the 2 poles of the battery. Now, they are pretty old school now at this stage. I don't advise using them. Look, you can still use them if you want, but hold them on for 5 seconds, 5-6 seconds at most, because they do short out the battery. They do generate a lot of heat. And if you have a battery that's only after been charged and you stick a high rate discharge tester onto it, there is an explosion risk. Because you have to remember that when a battery is being charged, it gives off hydrogen. So you have hydrogen gas coming off a battery as it is being charged. You have oxygen and hydrogen. So if you're charging a battery, you can have hydrogen in the air. You can have somebody say, oh, I'll test that battery now, put a high rate discharge tester onto it. You create a huge spark and huge heat, and the battery will explode. I've seen it happen, and once, it was many years ago in a farm machinery dealership, and the guy actually, he didn't use a high rate discharge tester, but what happened was he had a charger on the battery overnight, he came in one Saturday morning and he disconnected the charger while the charger was still plugged into the wall. So when he disconnected the charger, it created an arc between the terminal and the clamp. And when you have an arc, you have a spark, you have hydrogen in the air, and the top of the battery blew off, and he was very, very lucky that he didn't lose his eyes, yeah. So that is pretty serious. So when you're charging the battery, try to have it in a very well ventilated area. Have it on as slow trickle charge is best. Higher fast rate charges create heat and create gas and can cause them to bubble over. So that's the most important thing. So yeah, just back to testing the battery. So multimeter is grand. It'll tell you what volts is in the battery, what volts is in the system, but it won't tell you anything about how the battery is going to perform under load. So the modern way of doing it is you can use a battery tester, and that's a cheap enough Sealy one. It will do a good enough job, but probably one of the best ones on the market, Midtronics. Now this is the one that I would use daily. Midtronics tester for testing 12-volt batteries. Now I'm going to set up the camera. I'm going to run through how to test a 12-volt battery with the Midtronics tester. Very, very simple. So, okay, I have my Midtronics tester connected up to my battery. Positive to red to positive, black to negative, obviously. And what I want to do now is I'm just going to bring the screen up here just so you guys can see the screen. So I want to set test, okay? So in vehicle, no, keep going down. Out of vehicle, accept. So I want to set capacity. Now I know this is an 80 ampere hour battery, something around that. So it'll nearly always fall within this scale. So I'm going to accept that. So set type. So it's a regular battery. It's not a VRLA or an AGM battery. Regular, yes. So I'm going to set the standard now. So we're going to go by SAE. There's different rates there. You know, I'll talk about them in a little while. So SAE, accept, set the rating. So now this is my CCA or my cold cranking amps. So I want to set my amps on this one is 650. So I'll go up to 650. And I will accept. So testing now. Vehicle type, passenger car, we'll say. So 12.46 volts, good battery. Now, what that tester could have told me is replace battery, or it could say charge and retest. So that's a very, very simple there. That's that one there. It's not simple. It's simple to use, but it is a quite expensive tester. That probably is €500 or €600. That tester. Good old Daimler Chrysler. So I work for Mercedes, so that is why I have that one. You can get cheaper ones, but they're not just as good. Okay, so we've tested our battery. We know our levels are all filled. We know our terminals, our male and female terminals are clean. What we want to do then is try and implement some way to make sure that the battery stays warm. But when I say stays warm, keep the cold off it. So there are battery insulators that you can get that wrap around the battery. Now don't forget underneath as well, because if it's sitting on a steel cold surface on a tractor, you know, it will bring heat up, draw heat up in, or cold up into the battery. So what you want to do is maybe put a plastic or even cut a piece of timber, a piece of plywood or something and place it underneath the battery, or a piece of plastic on the battery tray. Bring it up off the ground, and if you get it, you can get an insulated battery insulators that can wrap around it, or you know, some form of insulation to try and keep it warm. That's probably the best way to protect it from as much from the cold as you can. Now, obviously, other things like leaving it inside in the shed, inside in where there's cattle, maybe instead of leaving it in the workshop, maybe park it in where the cattle are. You know, because you're going to have higher temperatures inside. A couple of degrees makes all the difference. So if you park it in the cow shed or something where there's cattle around, you're going to keep everything warmer. You also have to remember then your earth leads and stuff like that. So where your earth lead goes onto the body, you know, down onto the block or onto the chassis of the machine. Make sure that the bolts are clean. Make sure that the terminal is clean. give it a good rub of sandpaper, clean it off, put a little bit of copper grease maybe or something onto it, bolt it back up. Now this lead, as you can see, is rigid. It's, you know, it's solid. That's an old lead, and years and years and years of heavy current passing through them has broken away the copper inside in that cable. Now, if I take my multimeter, which I done earlier on, and I do a resistance check from the terminal to the earth point, I got 14 ohms, which is quite a lot. You know, 14 ohms resistance. Ohms is a measure of resistance. That's quite a lot in a cable that length. The other one just wasn't as bad, but is you know, it's definitely too high. So that's something else. Although your cable might look good and might be connected on well, and your terminal might be connected on well, you think you're doing a great job, but your lead itself, you know, they do break down over time. And if you've got a tractor that's from the 60s, 70s, or 80s, you know, there is a possibility that the same connection, the same lead is on it since the tractor was new. So it's no harm just taking it off, getting a new one made up, you know, stuff like that. That cable is not overly expensive for what it does. A couple of terminals onto the end of it, and you know that, you know, it all makes a difference. That will make a huge difference when it comes to starting from cold. That you have a good earth cable and a good positive lead cable going straight down onto your starter. Moisture as well can play a big part. If you've got a damp area, a damp workshop. If you've no option but to park a machine outside, when dampness gets into cables and stuff like that, it can also play havoc with them. So a spray of WD-40 over them, over the cables, over the terminals, over the connections, can help somewhat protect them from the damp as well. The other thing to remember then as well, to help and aid starting in the morning, is something that we spoke about before, is the type of oil that you have. So you should have the right oil in your machine for the right conditions. If you're in a cold country or it's getting down to -10, -15, you know, you want a lower viscosity oil in your engine that doesn't create drag. If you've got a heavy 15W40 oil in your engine and you're -15 outside, -20 outside, that creates drag. You have to get the pump going, you have to get the oil flowing. You know, it creates drag on the pistons, on the crankshaft, and that all as well. That all is going to, you know, cause resistance to the engine to turn. So when you factor in that, you factor in the cables, you know, it all leads back. You might not have such a bad battery after all. It could be a multitude of things down the line. So your oil plays a big part in it as well. Then obviously, you know, your glow plugs are huge. A diesel engine needs heat to start, and that's very, very important. It needs heat. A diesel engine is a compression engine. It's not a spark ignition engine like a petrol. It needs heat to create that explosion. So make sure your glow plugs are in good working order. Make sure that if you've got a flame plug, a heat plug, make sure that it's in good working order as well, because you know it all plays a part within the circle. So that's basically it on, you know, the care. So terminals, fluid, connections, leads, right type of oil. Make sure your engine is getting warm with your glow plugs. Make sure your flame plugs, your cold start device, whatever it is in your particular engine, that it's working efficiently and effectively. And also where you park the machine then as well can play a huge part. Instead of parking it outside or in a workshop, a cold workshop, park it in with the animals, because that few degrees that's in the air from the animals breathing and, you know, everything that they do, shiting or whatever, it all creates heat, and it all helps when it comes to start in the morning. So yeah, that's it. So I'm just going to zoom back over onto the battery. We're going to take a look at the figures that's on the top of the battery, and we're going to explain what each of those figures mean, because there can be a little bit of confusion with some people. Okay, so here we have our John Deere battery, our strong box. Now, the first number we're going to look at on the top, obviously, that's, anyone that knows John Deere knows that that's the part number of the battery itself. So anybody wants a strong box, this is your part number. So we're going to look at our figures here. So our first figure is 12 volts. So yeah, we've got a 12 volt battery. Our second figure then is our amp per hour rating. So that's our amp per hour rating. 88 amp per hour on this battery. We'll talk a little bit more about that in a minute. We'll jump over then. So we've got two ratings then for your cold cranking amps. So you've got an EN, which is a European normal rating, and then you've got an SAE rating. Now, these figures will generally be pretty much the same. There'll be there might be a couple of percentage difference between these two figures. It's a very, very similar test with slight differences. An EN test, there's a couple of stages to it, whereas an SAE test is one stage, and then we have at the end we have our reserve capacity. So we start with 88 amp per hour. So what does that mean? 88 amp per hour basically means that this battery will deliver 88 amps per hour. So what that means is if you have, say you had a 4 amp draw on that battery, so that would be 4 into 88 would be 22. So it will allow the battery to draw 4 amps for 22 hours before the voltage drops below 10.5 volts. So, and that is tested at, I believe, 25 degrees. Yeah. So amp per hour. So if you had a parasitic draw, if you had a draw on your battery, you left the lights on or something, the radio was left on, the 88 amp per hour tells us that, if you had 4 amps, if you had 2 amps drawn on it, if you had a 2 amp draw, which is smaller draw, 2 into 88 goes 44 times. So it will take 44 hours for it to draw below 10.5 until the battery reaches 10.5 volts. That's basically all that is. Now, the amp per hour it's important on modern machines because you have a lot of onboard electrics. You've got a lot of lights, you've got a lot of radios, you've got a lot of electronic components, control units, you have a lot of electrics. But older vehicles, like older tractors from the 60s and 70s, if you have a fuel gauge, you're lucky. You've got lights, and that's pretty much it. Like our 165, you could jump start it, you could take the battery out and the tractor would run all day because it does not need electricity to run. The engine is run purely on mechanics. There's nothing electrical. Now, you wouldn't have lights or anything, but it doesn't need electricity to run. Whereas more modern ones, they need electricity to feed all the different systems, to feed lights, radios, electronics, dashes, you name it, spool valves, solenoids. There's a huge demand for onboard electrical consumers. So we move on then to our cold cranking amps. So in this case, we're going to go, we tested at SAE, so we'll stick with SAE. So 650 amps, that's our cold cranking amps. Now that's not peak amps, that's not, a lot of people say, oh, that's the peak amp that it puts out. That's not the peak amps, that is the cold cranking amps. And the way the cold cranking amps is tested in a laboratory setting for this battery, what they do is they take it down to minus 17.8 Celsius. They crank it for 30 seconds, they put a load on it for 30 seconds, and that battery has to maintain 7.2 volts or higher. So whatever ampage that battery can deliver for 30 seconds at minus 17.2 Celsius will determine its cold cranking amps. Very, very straightforward. Lastly then, onto our reserve capacity. So what's our reserve capacity? Our reserve capacity is basically the battery is tested at 25 degrees and it will give us 25 amps. So they're all tested at 25 amps, 25 degrees, 25 amps at 25 degrees for 140 minutes. That's our reserve capacity. All right, so that's basically the numbers on the top of the battery. That's all that they mean. If you have an older machine, maybe it's getting a bit lazy, it needs a good spin to get it started. You want one with a high cold cranking amps, a high CCA rating. So yeah, now we know all about our battery. We know we have a good battery. We know what the numbers in the top mean. We know we've got good leads. We know we've got the right oil in the engine. We know that we're keeping it warm. So everything is perfect, as it should be. One other thing that I will mention that I would advise pretty much everyone to do with their machines, is an isolator switch. So anyone that doesn't have one already on their machine, an isolator switch will basically cut the battery from the machine. So you can put it on the positive lead, say going down onto the starter, put it on the positive lead. When you get off at night, some people, especially enthusiasts and stuff like that, that aren't driving them every day, they might be just driving them every couple of weeks and they're just parking them up. If you're not going to be taking the battery out of it, if you're leaving it for longer than 2 weeks, I would advise taking the battery out, especially over the winter, and leaving it inside someplace or covering it up in a rag or just keeping it warm. But other than that, an isolator switch that you can just get out and you can knock the battery off, so it's not connected to any system on the tractor, any lights or radio or anything like that, where anyone can get up and switch them on. Some young guy get up and switch the lights on or switch the radio on or something. An isolator switch is a brilliant job because it just isolates the battery completely from the machine and it will protect it. So if you are having issues, if it's not starting, if it's getting hard to start, there's a little booster pack that I have. Now that is just a one-shot booster pack. That will not start a machine from, a flat battery. If you've got a machine that's hard to start, if you've got a car or Jeep that's a little bit hard to start in a cold morning, stick that on. It will give you a huge amount of amps for a very short period. It will get something started, but it won't, you wouldn't be running around starting 5 or 6 machines with that. It's basically for one use. You put it on, you get a yoke going, and then you stick it back in charge. It goes on a docking station and you just slap it down. It's a very, very good machine, a good tool. I use that a lot. It's very, very portable, whereas some of the big booster packs, although they're great, they can be very awkward. And that one, I'm not sure what the amperage is on it, but it is a super tool. But for one shot, basically, to get a machine going. On the other hand, then we have something a little bit more expensive. This is a battery charger. It's for battery maintenance as well, and it will also do, say, if you've got something in a showroom or that. So I'll just zoom in on that, and I'll have a quick talk through that before we get on to our antifreeze. So yeah, this is our GYS battery charger, battery maintenance and support unit, and now these are very expensive. This is a 50 amp one. It's one of the smaller ones. You can get them up over 100 amp. So we have it in diagnostic mode here at the minute, as you can probably see. So what that will do is, when I'm working on a machine, when I'm working on a car and I need to have the ignition on, I need a diagnostic tester plugged into it, I need to maintain that battery because the battery will go flat very, very quick. So I can put it onto diagnostic mode and I can start it and it'll kick out whatever amps I want. And there's no much drawing at the minute. It's putting out 4.2 amps, but it can go right up to 50 amps. It'll simulate what an alternator nearly would put out. Our other modes on it then, we have showroom mode. So basically, if you've got a machine, a car or whatever in a showroom, and you've got people constantly getting in and out of it and opening doors and turning on ignitions and stuff like that, you can hide that underneath the car. You can hide it underneath the tractor or someplace in the tractor or inside in the combine. If it's, if there's people looking at it, and what you'll do is you'll just hook it up onto the battery or onto a positive terminal someplace safe, and you leave it on showroom mode, and that will just keep the battery ticking over. It won't allow it to go flat. And very, very handy tool for that. Also then you'll have your charge mode. So then you can scroll through, a fast charge, easy charge, or slow charge, whatever charge you want. Hit your start button. She'll start throwing out whatever amps that battery needs. So I'm going right up to 93% already. So that battery is in very good condition. Now I have to add, that battery actually has been lying up for a year and over a year, 15 or 16 months, and the battery is still perfect on it. Those John Deere batteries are fantastic. Yeah, so it's at 95%. I haven't touched that battery since I brought it in here to show this. So that's it. That's the GYS. Now they are nearly €1,000, but they are fantastic. You could not work in a modern workshop without something like that. So that is it. That's the high end of the scale. We'll just look at a smaller battery charger now before we finish up on the batteries. It's also important to note at this stage the role that our alternator has to play in maintaining a good charge in our battery. So just briefly touching it, we should always be looking at least once every couple of weeks, checking our alternator belt or dynamo belt, whatever you have in your system, making sure obviously that you have good connections, that your belt is well tensioned. If you have any doubts that your alternator is not performing as it should be, stick a multimeter on it to see what your output is. So you're roughly looking at 14.5 volts output from your alternator. When there's not much load in it, then if you switch your lights on, switch on a few consumers, it'll drop down to 13.5, roughly 13.5, 14 volts. Now, if it is a thing that, you're running a lot of extra electrical stuff on your machine, if you're running extra lights or if you're running extra fans and stuff on different implements, it could be worth operating your alternators. If your alternator is putting out 100 amps, 120 amps, I would talk to your dealer or your mechanic or auto electrician just to make sure that the alternator that you have on your machine is correct for your application. So yeah, the alternator is obviously very important in maintaining good battery health. And that's just then, again, at the cheaper end of the scale, more than capable of charging any battery. It's an X-side, so it's made by the battery people themselves. X-side battery charger, very, very simple, not very expensive, less than €100. And that one gets used regularly. That is a very good battery charger. And does different settings on it as you go through them. You can set it for whatever speed, whatever you want. It'll do a standard battery and it'll do an AGM battery as well. So just be careful with some battery chargers. They're not up to charging AGM batteries. Now AGMs, you can put them into anything. You don't have to have it. Lead acid batteries are fine for most applications and machines. But an AGM battery would probably be twice the price, but they are fantastic. So that's it. Yeah, that's just the cheaper end of the scale. It is one of the better ones. You can get Sealy and you can get some other ones that just, they're not brilliant. But that's a fantastic battery charger, and the GYS then is the cream of the crop. But completely overkill for anybody in a fireman situation, unless you're a technician or something, you're working on them. One thing to point out, anytime you're working with batteries, if you're after charging them, if you're after doing nothing with them, and you're taking off the leads, as I said, switch it off at the wall first. Take your leads off, and always wear eye protection, especially around the battery that's just freshly been charged. Switch it off at the wall so you'll have no arc and you'll have no spark. And always be very careful around them, because they are dangerous, and if one of them blows up, it will destroy you. It will destroy your face, as I know I have seen happening. It's not nice. One other thing to mention then as well that I forgot to mention: when you're putting your leads on, when you're connecting a battery, a lot of people mightn't be familiar with the procedure for connecting or disconnecting a battery. So when you're connecting a battery, always connect the positive lead first. So put the positive lead on first, tighten it up, then put the negative lead on and tighten it up. Okay, no, I'm not going to tighten it because the two of them might touch. But and then put the negative lead on. When you're taking them off, take off the negative first, then take off the positive. The reason we do that is, if I put my negative on first, I tighten it up, and then put on my positive, and I'm starting to tighten it with a spanner, what can happen is the spanner can short off a bracket or a frame or something's inside in the cab or underneath, wherever the battery might be, and it can short out. You can short it out with a spanner. So be very, very careful. Always make sure that you're connecting the positive first, and tighten it, and then the negative, and then when you're taking it off, take off the negative first and then take off the positive. So that is it for batteries. I hope everybody got something out of this. The main thing is to check the levels, check the connections, check the leads, check the earths, and keep them warm. Check your glow plugs, check your cold start device, and if all of that is right and you've got decent compression in your engine, there should be no reason that it shouldn't start when you want it to start every time. So that's it for batteries. I'm going to have a quick talk now about antifreeze, and we'll wrap it up there. Just a quick talk on antifreeze, two different types of antifreeze, and basically how to test it, and a couple of things just to look out for. It's also important to note at this stage the role that our alternator has to play in maintaining a good charge on our battery. So just briefly touching it, we should always be looking at least once every couple of weeks, checking our alternator belt or dynamo belt, whatever you have in your system, making sure obviously that you have good connections, that your belt is well tensioned. If you have any doubts that your alternator is not performing as it should be, stick a multimeter on it to see what your output is. So you're roughly looking at 14.5 volts output from your alternator. When there's not much load in it, then if you switch your lights on, switch on a few consumers, it'll drop down to 13.5, roughly 13.5, 14 volts. Now, if it is a thing that, you're running a lot of extra electrical stuff on your machine, if you're running extra lights or if you're running extra fans and stuff on different implements, it could be worth operating your alternators. If your alternator is putting out 100 amps, 120 amps, I would talk to your dealer or your mechanic or auto electrician, just to make sure that the alternator that you have on your machine is correct for your application. So yeah, the alternator is obviously very important in maintaining good battery health. So moving on to our antifreeze. Obviously, this time of the year, very, very important to make sure that you have an adequate supply of antifreeze in your engine, in your cooling system. Why is it there? Well, we all know when water freezes, it expands. A cooling system is a sealed unit, and when it expands, it will crack a block, or it'll crack a hose, or it'll crack a heater matrix, or an EGR cooler. It'll be the most awkward thing that you can get to, that it's going to do harm to. So it is vital that you have an adequate supply of coolant in your or antifreeze in your engine. Now, we do have on the side of engines, we've got plugs. Now, everybody calls them frost plugs, and they do act as a frost plug, but that's not why they're there. They're not there. It's a myth that they are frost plugs. They're not frost plugs. Those plugs are there basically from when the engine was cast, and the sand inside in the cast, it's basically to make sure all the sand is gotten out. And then there is a name of them. There's a term for them, a technical name for them. I just can't think of it off the top of my head. But they are there to plug the engine after the casting. They're not there to stop the to prevent it from cracking when it freezes. That's not why they're there, although they do that. They pop out, but they don't always pop out. Some engines, they won't pop out. They will, the block will crack, or something will crack. It's important to know that that's not why they're there. They are there from the casting process, and from when the sand inside in the casting was been extracted. That's what those holes are there to allow the sand out. Just a little fact that a lot of people get kind of mixed up on, but they do act as frost plugs, and it is important that if you've had a hard frost and you think, maybe, my coolant isn't great, just have a quick look at them, have a look in, make sure there's no leaks or they haven't popped out or something, because they do pop out. So on the antifreeze itself, so we've got two different types of antifreeze. Modern antifreeze is organic. Not all vehicles will take organic antifreeze, and older ones will take inorganic. Now, the difference between them is the additives that's in them and what they're made up of and what they do. The organic one is there mainly for engines that are more aluminium based, and it's for an anti-corrosion inside in the engine. Now it's important that you don't mix the two. That's the most important thing. If you mix organic and non-organic, they are inorganic, they can react with each other and they can cause, you know, a sort of a creamy substance, a paste that won't flow properly. It will react, and you'll actually get growth and stuff inside in the engine. So always consult your handbook, your owner's handbook. Look it up online. What's the correct? Generally, the organic ones are they're going to be red. So a G12 organic antifreeze, it's going to be red. So that one there, that's an organic one. That's red. Whereas some of the other, most of the other ones are green and generally green. But do not mix the two of them. Don't be tempted to just pour a little bit in just to top it up. You're better off without it. And how do we test it then? Well, basically, there's a couple of ways of testing it, but that's just a simple hydrometer. Now, this one has a floating element inside in it. Some of them have floating balls, so it might have 5 different color balls, and depending on how many balls float, you'll read off a scale and it'll give you a ballpark figure of where your protection is up to, so to your minus figure. So what I have here actually is I've got water and I've got a proper concentrate of antifreeze, and I'm just going to test the two of them. I'm going to show you on the scale how it reads. So we'll pretend that our radiator cap is here. So I'm just going to zoom in now and we'll do a quick little test and show you how this tool works. So yeah, here we have our 2 antifreeze in the cups that were disposable cups left over from my daughter's christening. So we'll go with the water first. So we're going to get the tool and we're going to dip it into the water. So it has a little suction on it. So you press the suction device, unit, diaphragm, whatever you want to call it, at the top, and you will just let it fill up. Now, as you can see, how well you're going to be able to see that now on the screen. But, oh, here we are. We can see that we've got no float on that. So, zoom on that. It's on the black line, so it's water, it hasn't floated. So what we're doing with this tool is we're measuring the density of the fluid, the specific gravity of the fluid, and the element, depending on the specific gravity of the fluid, will float to a certain level. So that hasn't floated at all, obviously, because it's water. That's what it's designed to do, designed not to float. So we'll squirt that back out. We'll take a dart of our good quality antifreeze. So just take off the rag cap there. Yep, rag cap off. Be careful, obviously, taking off rag caps. Don't open the system when it's under pressure. First thing in the morning, check it in the morning time. Check it when the engine's cold. Don't be tempted to take a rag cap off when the system is hot and under pressure. Very dangerous. So, I can see already our flow has started to rise. I'm looking on my scale here. Never mind the dirty hands. Very hard to read. I can just read that. Minus 34. So you're down to minus 34 degrees protection. So that's what we want. Again, always make sure that you're buying the correct antifreeze for your vehicle. Whatever antifreeze you get, always read the instructions. If some of them, you buy them in a 20-litre drum, you have to mix it 50-50, or it might, some of them come, mixed. You don't have to, depends on the concentrate of them. Some of them you just put them in neat. Some of them you have to water down. So that is it for tonight. I hope everybody got something out of this. There's lots to learn there, lots to be careful of as well. You're dealing with batteries and you're dealing with coolants and pressure systems and hydrogen gas and sparks and everything. Can be quite dangerous. So please always, use your PPE, pair of gloves when you're working around machinery, and just be careful. Don't want anybody getting injured. So that's it, yeah. So if anybody has any comments, anything they want to add to it, if you've seen any disasters with cracked blocks due to freezing conditions because of the lack of antifreeze, or you've seen someone with a battery that blew up or something, please let us know in the comments. I hope everybody found this a little bit helpful. Longer video than usual, but there was lots to talk about. And I'd just like to say thanks to Martin, who asked me to do a video on batteries. Basically, just might help some lads to understand what the amperages are and what they should be, and a little bit of maintenance around this time of the year. So that's it. That's it for tonight. Don't forget, on Sunday, the first of our Massey Ferguson series videos on the TE20 will be coming up, and it'll be one to look forward to. So until the weekend, have a great week and stay safe, everybody.